We're now going to have a look at how we synthesize amines. I'm going to split that up into two. So we're going to look at how to make an aliphatic amine first, and then have a look at how to make aromatic amines. And within aliphatic amines, there are three types. So we're going to look at primary, secondary, and tertiary. So let's start off with a primary amine first. So how to synthesize this. Now it's a two-step process. In the first step, what occurs is nucleophilic substitution. The reason being is because the reaction that we see is going to be between ammonia and a haloalkane. Okay, so reaction between ammonia, NH3, and a haloalkane. I'm just going to go for the simplest one I can think of, which is chloromethane. The reason why this can undergo nucleophilic substitution is because our ammonia has a nitrogen with a lone pair. The definition of a nucleophile is a electron pair donator, so therefore our ammonia can act as a very good nucleophile, and it can substitute the chloride in our chloromethane, and it will give us this salt over here, like that. Okay, if I draw out the mechanism just to remind you what I mean by nucleophilic substitution, if we have our haloalkane drawn out like that, we have a dipole going across that bond there. We've got our nucleophile, which is our ammonia with a lone pair of electrons. That's going to form a bond with that carbon there. The carbon-chlorine bond needs to break. That's going to then give rise to this molecule here with a positive charge on the nitrogen because it has donated its pair of electrons. You've still got that chloride that's been kicked out hanging around, and therefore you form this ionic salt over here. Okay, so that's what I mean by nucleophilic substitution. You form the salt in step one, and obviously that's not the primary amine that we want, that's a salt, and therefore step two is just reacting the salt with sodium hydroxide, and what that does is it releases our primary amine. So if I just do the equation for this, so react with sodium hydroxide, that's going to release the primary amine that we want, which is this. And so that is methylamine, and it's also going to release NaCl and H2O as other products as well. Okay, so this is the two-step process to form a primary amine. You react ammonia with a haloalkane to form a salt. Then you react that salt with sodium hydroxide to release your primary amine and some other products as well. Okay, now there are two things that are very important in this process in terms of the conditions. Condition number one is the solvent that we use. I'm just going to write this at the top over here. So the solvent that we use is very important. You have to use ethanol. And the reason we use ethanol is because we don't want any water present. If we have water present, if you remember, water also has, I'm just going to write this over here, water also has a lone pair of electrons, and therefore it can act as a nucleophile. Okay, you don't want to have two nucleophiles in the pot, they're going to compete with each other. So what could happen if you have water in the pot is that water can undergo nucleophilic substitution with the haloalkane and give another product, it will give an alcohol. Okay, so we don't want to have water present, that's what we don't want, and therefore the solvent that we use is ethanol, so there's no water present. Okay. The other condition that you need to do or need to use is that you must use an excess of ammonia. So in step one, when we have ammonia reacting with a haloalkane, you must use an excess of ammonia, and this is important to form a primary amine. Okay, if you don't use an excess of ammonia, you form the secondary and the tertiary amine, which we'll look at in a second. So for a primary amine, you must use excess ammonia. Okay, the reason being is that once you have formed the primary amine, if you don't have an excess of ammonia, this can undergo further substitution back with that haloalkane, which we're going to have a look at now. Okay, so for a primary amine, you must use excess ammonia, otherwise further substitution will occur, and that's going to form, as we'll see now, our secondary and eventually our tertiary amine. So to produce a secondary amine, so we've done the first step when we were forming our primary amine, and what we did is we produced our primary amine, which was this, okay, with a lone pair of electrons. So we form the primary amine. Now, if you don't have an excess of ammonia, that primary amine can react further with that haloalkane we had at the beginning. Okay, so again, we'd have lone pair of electrons going to kick out that chloride, and it's going to form this salt. So that nitrogen now has 2 methyl groups attached to it. Like that, it's going to form the salt. Okay, if you have an excess of ammonia, ammonia is going to be the one that reacts with that. If you don't have an excess of ammonia, the primary amine that you make is going to react with that, and that's just going to lead to further substitution, as you're seeing over here. Okay, and obviously once you formed that, step 2 is where that reacts with sodium hydroxide. And as you can see now, that's now produced a secondary amine like that, and it's also produced NaCl and water. Okay, so if you don't have an excess of ammonia, further substitution will occur, and that's going to lead to a secondary amine, and obviously if it's not usually going to stop there, that secondary amine is now going to react further in the presence of that haloalkane, and it's going to form our tertiary amine. And it's just the same steps as before. Because we don't have an excess of ammonia, that secondary amine that we just formed, which was this, reacts with another molecule of haloalkane, forms this salt here. You just react that with sodium hydroxide, so I'll just write that out. Like that. Okay, and we've now formed our tertiary amine. In this case, it's trimethylamine. Okay, so yeah, the important thing here is that if you're trying to make a primary amine, you must use an excess of ammonia. If you want to make a secondary or a tertiary amine, that's when you don't use an excess of ammonia. Ammonia will then be the limiting reagent, and that will give rise to that further substitution, and therefore to secondary and tertiary amines. Okay, and again, just remind yourselves that the solvent that you must use is ethanol for all of these. Right, so let's now have a look at how we make an aromatic amine. So you might have come across this before when looking at aromatic compounds. So how to make an aromatic amine. The simplest aromatic amine that we can make is phenylamine, which I'll just draw out here. So it's where an aromatic ring is directly bonded to the nitrogen. This can be made through the process, through reacting nitrobenzene. Okay, so phenylamine can be made from nitrobenzene. I'll just write these out here. Nitro. Okay, like that. To do this, the reagents that you need are, so it's a 2-step process. For step 1, you must have tin, so the symbol for tin is SN, and you must have concentrated hydrochloric acid. Okay, from that step there, what you actually produce is the salt. So if I just draw this out so you can see what I'm talking about. So you form this salt here, and then in step 2 you react this salt here with sodium hydroxide. So like we've been doing for aliphatic amines as well, to get rid of the salt, we react it with sodium hydroxide, and that then gives rise to our phenylamine here. Okay, so yep, you need to have both. You need to know both those conditions: tin and concentrated hydrochloric acid, and then sodium hydroxide. As you can see, this equation is not balanced, so let's have a look at how to balance this. As you can see, you've got 2 oxygens here, no oxygens here, so that's why you need to produce 2 water molecules over here, and then you need to balance the hydrogen. So I'd count the hydrogen on this side, so you've got 4, 5, 6, 7, 8, 9, 10, 11, but you've only got 1, 2, 3, 4, 5 on this side. Okay, this reaction here is actually a reduction reaction. You are reducing this nitro group here, so this is a reduction reaction. So the tin and the concentrated hydrochloric acid do the reduction part of this. So you are reacting it with a reducing agent, so I'm going to put H in brackets there. To balance it, you therefore need to have an extra 6 over here, and now that equation is balanced. Okay, this kind of this synthesis, this transformation is quite important in terms of directing groups. Nitrobenzene, the nitro group, is 3 directing. If you do this reaction here, you then form your amine group here. Amines are 2, 4 directing. Okay, so you've changed the directing groups here, and therefore if you are doing a synthesis with this, you can change where that the next substitution will occur.